All right, so I'm going to be doing this kata today. It's called English Beggars. Born a misinterpretation of this kata. Your task here is pretty simple. Given an array of values and an amount of beggars, you are supposed to return an array with the sum of what each beggar brings home, assuming they all take regular turns from the first to the last. For example, 1, 2, 3, 4, 5 for two beggars will return a result of 9, 6. As the first one takes 1, 3, and 5, and the second one collects 2 and 4. Let me digest that for a second. So two beggars, first one gets 1, 3, 5, second one gets 2, 4. Okay, so first beggar gets this, second beggar gets that, first beggar, second beggar, first beggar. So 1, 3. That makes sense. The same array with three beggars would have in turn produced a better outcome for the second beggar, 5, 7, 3. So 1, 2, 3, 1, 2. Also note that not all beggars have to take the same amount of offers, meaning that the length of the array is not necessarily a multiple of n. Lengths can even be shorter, in which case the last beggar will, of course, take nothing, 0. And don't think any of that is relevant. I want to try it with this example that they give us, 1, 2, 3, 4, 5. And so let's use values equals this. Need another bracket. And I want to try the example where I think the variable is in, where we have two beggars. And I'm trying to think of the best way to do this. So I could like iterate through this values. And maybe see if it's divisible. I don't think that's gonna work. What if I did values? If I grabbed every other number, so it'd be every other number would be this. So this will grab every other number, and then if I wanted every other number starting at 1, I could do that. So that's 1, 3, 5, and 2, 4, which I think is correct. 1, 3, 5, and 2, 4. Now let's do the same thing for three beggars. So the first person would get this, 1 and 4, which is correct. The second person would get this, 2 and 5, which I believe is correct. And then the third person would get values, I think it would be 2, would get a 3, and that is correct. So I have this pattern here, and I kind of starting to see the pattern is I want to iterate through this as opposed to values. So the first time this is a 0, second time it's a 1, third time it's a 2. And this is for three beggars, of course. So this would be 4 I in range of n. And let's just print I. So I have 0 the first time, 1 the second time, 2 the third time. And if I do values I double square brackets and then n, that works. So with list, with us list, I think this is called like list slicing, but this is your starting point with a list. This first square bracket, or not square bracket, but there's 3 numbers you can put in. And I don't know why I have 2, but you can put a number right here. This is the starting point for the list. So if I want to start with number 3, it's going to return everything to the right of number 3. But then this is your ending point. So if you want to end, let's say 4, then it's just going to get 3 to 4. And then this is if you want to have any sort of jumps. A lot of times I'll use this to like reverse a list. So this would reverse it. If I wanted, I think reverse every other. If I want every other number, though it can be useful. But back to this problem, I don't want to just get the numbers. I want to sum them. So sum. So 5, 7, 3. For the 3 beggars, let's try it for the 2 beggars. 9 and 6. 9 and 6, which is correct. And then let's try it for 1 beggar and see if make sure that works. 1 beggar gets everything. 3 beggars, 6. Let's try. I'm going to try all these test cases. 6. So first beggar gets 1, second beggar gets 2, 3, 4, 5, and 0, which is correct. And then finally 0 beggars. This is the one I was really curious with if it would work. For I in range of n, correct I. And this returns nothing. So I think what I want to do is make a variable my list. And instead of printing, let's append to it my list.append. And then at the end, I'm going to return my list. So I think it does work. 15, 2 is 9 and 6, 3. That's good. And let's try that 6 again. Cool. Yeah, so I think that this does work. Let's try running it, of course. Return my list and test. Passed all the test cases. Now let's see if it works on everything. So cool. Looks like it worked on everything. So that is my solution. Let me know if you have any questions. Thank you.